So let's say you found the skeleton. How would you tell it's a dinosaur? You personally, how would you decide?
Well, interesting question. I don't know. I'd have to do some research on that.
This kind of feels out of context, but
No, please. Open
But,
conversation.
the measurements that is often used is in cc's, right?
Yes.
Okay. So, and that measurement is usually used to, if it falls within this range, it's to this, or it's probably closer to that, right?
No, that so what they do is they'll measure the full brain case volume, right? And then they'll say, all right, this is what we have for the brain case volume. That alone may cluster within this species or this species based off of what we know. But at the same time, the postcranium may create problems. And if the postcrania matches, like, they'll basically take the entire hypodyme of the species, right? So let's say I go out.
I think hypodyme might need a definition.
Yeah, so the suite of characteristics that define a species. This is the unique set, full-on set of characteristics. If that doesn't match anything that we already have, then it typically gets a brand new species. Or, depending on how extreme it is, it might be a regional variant. And if you're thinking, boy, that sure sounds like it's kind of arbitrary, that's because it is.
Yeah, species are human conventions. They're not a real thing in the real world.
Right, which is
Right.
why when you get things that are really close together, it gets very blurry on what is a variant and what is a new species. So if I go out to South Africa and I start chiseling around and I come up with a brand new skull and maybe 40% of the postcrania, and I say, okay, I'm trying to figure out who all this belongs to. You know, I'm in South Africa, so it could be Australopithecus africanus, it could be Australopithecus sediba, it could be Homo naledi, it could be certain variants of Homo erectus or Heidelbergensis or whatever. But I've got this, I don't know anything about it, and now I'm like, let's figure out which one it clusters into. So I would go and I would take measurements of all the characteristics. So let's say that this, for instance, is the skull that I find. I take the cranial volume, the brain case volume. I might measure the angle of the zygomatics. I might measure the angle of the prognathism. I might count the cusping on all of the teeth. I might see if there's a retromolar gap. I'd measure the length, or the breadth rather, of the ramus and the length as well, the body of the mandible, whatever. All you get what I'm saying. I would just take as many measurements as possible from the skull as well as from the postcrania, and I would put all of those into a statistics software like R, for instance, and I would cross-check it with what we have for everything else. Now, depending on what kind of test you run, perhaps you might get it where it's like, okay, well, with regard to the dentition, it's closest to, I don't know, Homo habilis. But with regard to the cranial, the brain case, it's closest to Homo erectus. And with regard to the measurements of the mandible, it's closest to Australopithecus africanus. And the postcrania most closely also matches Homo habilis. So with all of that, I would say, okay, it kind of looks like we've got a new species on our hands. And then I would run an additional test, in all likelihood, where I'm like, okay, does this fall within a margin of any of the variants of what we have? Or is it even close? And if it is, then I might be like, okay, well, it looks like this is just a very specialized version of Homo habilis. Maybe because it was under certain environmental pressures, it responded in such a way as to grow more basal in some ways and more derived in others. And the way that I would do that is maybe I would look at the conditions, the paleo environment that this organism lived in by taking like geochemical samples from the rock, whatever. But I might also find that it doesn't fall within that range, and it truly is all by itself. So then I'm thinking to myself, okay, this kind of looks like it's a brand new species. Its hypodyme is unique, and while some traits match other organisms, the entire suite is unique. That's how I would decide if it's a brand new species. So that's the long way of saying, no, it's not just the crania, I make this mistake every time. It's not just the brain case size that we would use to decide where it falls, the brain case size is merely one piece in equal consideration with all of the other characteristics that typically go into a hypodyne for a hominin.
Does that answer your question, Kane?
Pretty well.
Okay. So I think then...
Because...
Sorry, go ahead. Oh yeah, I'll just go. So I guess what I would then like is for... What is your response to the question that we had asked earlier, which I can basically summarize as saying, rather than having strongly clustered brain case sizes or skull morphology in general, after a pretty thorough literature survey, the consensus both among professionals in the field as well as interested people in tangential fields like Erica is that in fact we do not see strong clustering between genus Homo and genus Australopithecus. Instead, we have such a smooth gradient that there are specimens where it is difficult to determine which genus they should belong to. And you can pick a brain case and you can find it.
To specify very quickly, Dapper, you can see strong clustering if you get really, really broad, right? Like, you can get strong clustering if you're like, this is the overall range for what we consider genus Homo, for sure, and this is the broadest range for what we consider Australopithecus, for sure. The problem is there are a lot of species that are still subject to potentially moving around because they're so gradient-based in their
So
So then you would say, okay, well, what about Australopithecus sediba? It falls outside of the Australopithecine range a little. And what about Homo habilis? It falls out of the Homo range a little. And so then that gap is bridged with these weird organisms that could in some ways be derived and basal in others.
So yeah, that basically sums it up. Is it seems like while there might be some clustering in a broad enough sense, there are organisms that are right exactly where you would want them to be in terms of transitioning from one group into the next. And
yes, I would say that that's fair.
Yeah, and then, in fact, humans are actually in sort of a unique place paleontologically, where we can say with pretty high certainty that certain species in our, in the paleontological record for hominins are directly ancestral to a modern species. We almost never can make that determination in paleontology, but we have so much data on that we can say pretty certainly that, let's say, Homo erectus is probably ancestral through a few other species, probably, to Homo sapiens.
Yes,
and
you can do that to a certain point, absolutely.
Yeah, so it just seems to me like this is a very odd sticking point for evolution, because far from being a poor fossil record where it's hard to tell what's happening, the fossil record for what I'm going to call STEM humans, I'm just going to do it. I'm going to call them STEM humans, Erica.
Please don't. Please don't.
It's too late. I just did. The fossil record for STEM humans, if you will, strokes his beard.
No, you don't have a beard. You're a dinosaur.
I could grow a little. I'll put on a fake beard, and I can barely stroke it.
A little filament beard.
I had a mustache in one video.
Oh, little ceratosaur mustache.
But anyway, yeah, it is so good that we basically have a completely smooth grading. You can, like, I'm sure you've seen the pictures, but like, if you were to just take, say, reconstructions of all these skulls and just smoothly morph between them, you would have to do very little interpolation between one skull and the next. We have basically the entire animatable sequence. And so,
yeah.
What's the gap? Because I don't think there is one, unless you just say we don't have literally every individual who has ever lived as an extant fossil, which I will grant you, we do not. I don't think that's a reasonable standard, but what's...
Behavior is the other thing. You could do it with behavior. You could say, all right, the second we see art, that's true humanity. Or the second that we see fire, that's true humanity.
But the problem there is, the problem I see there is, I don't really care what you consider to be a human in terms of like your definition. For me, the question is, do humans share common ancestry with, say, the chimpanzee, right?
Well, and that's what I was going to say, Dapper, is that you can draw those lines, and you could even say that, like you could even go so far as to say, okay, what we as humans consider humanity appears at X hominin. The problem is that you're correct, and that ceases to be empirical in a sense of, does that have any bearing whatsoever on common ancestry? And the answer would be no, particularly because we see organisms of all types, weirdly enough, utilize, for instance, fire. Like there are fire kites, that one type of bird that will pick up the remains of forest fires and drop them in new locations, because they know that when they set an area ablaze, it flushes out small critters that they can eat. Would you call that utilizing fire? I mean, maybe. I don't know. If that's the case, if it's not, right, because it didn't start the fire, what about all the hominins that potentially utilized fire in the case that they took it from existing forest fires and kept it alight for generations even?
That could include Australopithecus.
It very well might.
There is some reason to think that there is at least one group of humans who currently, like modern Homo sapiens, who currently do not have the capacity to start fires. They do not know how to do that, and it's the North Sentinelese. They are routinely monitored by satellite and helicopter because it is illegal to set foot on their island because they like to kill people who do that. Yeah, but and of course they're an essentially they're not entirely uncontacted, but they are essentially an uncontacted people group who have been in isolation for more than 10,000 years. So chances are any significant contact would simply wipe the population out, and the population is estimated to at most be in like the low hundreds. So but yes, as far as I know, there have been no reports of new fires being started on the island ever. So yeah, even if you just take just Homo sapiens, modern extant populations of Homo sapiens, you have a gigantic variation in how much of the quote-unquote human behaviors they engage in. So,
well, here's something very interesting, very briefly, to add to that is typically in the field of the theory of mind in animals, one of the ways that for a long time humans have dictated that other animals have self-awareness is by performing the mirror test, where they take a dot of paint and they put it on the forehead of an animal and they set them in front of a mirror. And if they look at the mirror and then they go and wipe the paint off their own forehead, then they have, at least according to what we think, a theory of mind, because they're capable of seeing their reflection, saying, that is me. Why do I have paint on my forehead? And then wiping it off. The problem with that is, very interestingly, that we have for so long done that test and said, okay, it ends at rhesus macaques. Rhesus macaques can do it earlier than rhesus macaques can't. Dolphins do it. Pachyderms do it. Therefore, these are the animals that have self-awareness. But if you perform this test on children human children that grow up in rural areas, they fail the test because they don't frequently see mirrors. They don't understand their reflection, and they'll fill it up to the age of 6, which is absolutely insane. That to them, they see this and they're like, what's going on? And the interesting thing is, the animals that do indeed pass the mirror test are typically lab animals, which is to say that they see their reflection in the sides of their cages, in the glass around them, things of this nature.
Metal tools, stuff like that.
Right, and it suggests that passing the mirror test, even for humans, is at least in part due to exposure and experience. So understanding the nature of what self-awareness is and how we can even catalog it is very difficult. And it adds an additional kind of layer into, okay, well, what is innate for humans even? What do we have that's innate, and what is truly learned? Because obviously the passing of information from one individual to another generation of individuals is what is considered culture, and lots of animals do that.
Yeah.
So where do you draw the line? I mean, I'm far from one of the people that's going to be like, yeah, humans are not special in any way. All animals are special in some way. We all have something that we do that's just incredibly unique. At least the vast majority do.
If you didn't have something unique about you, you wouldn't be an identifiable species.
But yeah, I mean, I think you could potentially say that. Although, again, that crosses into like, okay, well, does unique behavior, does that make you unique? Because behaviors are very frequent. Like, you could look at 2 populations of dolphin, for instance, and be like, well, one of them gets high on pufferfish venom and then one doesn't. is it a unique species because of what it does? Morphologically, no. Phenogenetically, no. Phylogenetically, no. But if you give them long enough, like give them 1 million years, if that pufferfish venom, getting high on pufferfish venom has some kind of fitness benefit, you may start to see a morphologic response. And in evolution, that's typically what we see. Behavior comes first, then morphologic change, and morphologic change will leave before behavior does as well.
I was just gonna say, I love that there's stoner dolphins. That's a real thing.
I know. And a stoner, a lot of animals, like jaguars will accidentally eat ayahuasca and then come back for more. So
Nice. Yeah. Yeah, it turns out that even recreational drug use, not a uniquely human thing.
Right, and I want to make something abundantly clear, because from what I know, you're an older creationist, right? Like, there are a ton of religious individuals out there who are even anthropologists, and paleoanthropologists, and things of that nature. That accepting human evolution, I really recommend that you check out the work of like John Walton and stuff, because there is nothing about accepting human evolution, at least from what I've read. And I used to be a young Earth creationist, and then I transitioned into, I never really had an old Earth thing. I was kind of immediately to theistic evolution. But I read a lot trying to reconcile in my brain what I saw in nature with what I saw in scripture. And I went through probably 1.5 years of reading a ton of stuff about, okay, is the interpretation of Genesis, is it meant to be allegorical? Is it potentially meant to be a temple analogy? Is it kind of metaphorical, but kind of not? And there is so much out there that makes a lot of sense scripturally that can reconcile human evolution with Genesis. So I want to be very clear. I don't think that you have to, I don't think that you even should by any means. I don't think that there's anything reasonable in human evolution that would make someone give up their faith by any stretch of the imagination.
I would agree.
Yeah, and I've actually never met someone who human evolution is what did it for them, where they were like, yeah, I saw that humans were primates and were evolved from a common ancestor with chimps, and I couldn't reconcile it with the Bible. Usually it's something much more personal.
Morphologically and genetically, humans are definitely structured as apes.
Yeah.
Thank you,
There is
King.
Good. It's good to.
that can get you past that.
It is good to hear.
I wholeheartedly agree, and I don't think again, you don't have to like take the common descent step to see that, right? Like you don't have to. It's just, but it's like if you're going to include humans as living things and put them into the tree of life, barring just not talking about common descent at all, you end up with humans as primates and humans as apes, etc.
Yeah,
like Carlos Linnaeus was like, yeah, that's what you're gonna do.
Carlos Linnaeus wanted to put the orangutan in the same genus as humans.
Which what a step, right? Including orangs, that's a biggie. I mean, orangs are the outgroup by quite a bit,
right?
Almost as much as gibbons.
Well, so one of the things was that at the time it was one of the only apes that was well known to Europeans because they could get it from trade routes, whereas all the other ape species, or at least great ape species, lived deep in the jungles of Africa, where Europeans were not hanging out because they would die of malaria in a week.
Yeah, one of my friends, actually my French friend, she just got a job working in the in the DRC with bonobos. She's working on a bonobo field site there, and she was like, I really was trying to decide between this, and there was also a gorilla site in Rwanda that she was maybe going to work at. And she was like, of course, I can't go anywhere like that because the United States is still banned from so many countries, but the French can go, so more power to her. I'm so jealous, but I am very happy for it. And she was like, yeah, I ended up choosing the bonobo site, even though the field site itself is so much more rudimentary. Like, they've got no internet, no running water, solar power that sometimes works, and a satellite phone that they can use to dictate emails to be sent from the nearest city. The nearest village is a 25-kilometer walk away. So she was like, yeah, they literally get there by plane. And so she was like, yeah, I ended up choosing bonobos because, and I didn't know this. This actually blew my mind, but I was like, wow, that actually makes a lot of sense. Bonobos weren't even discovered until like they were discovered less than 50 years ago, officially.
Yeah.
And I was like, oh my God. And she was like, we just know so little about them. She was like, I want to contribute to the big L literature on them. We know so much more about gorillas, but we know almost nothing about bonobos.
Yeah, specimens of bonobos were known from before that, but they were treated as just a regional variation of Pantroglodytes and not as
pygmy chimps.
Yeah,
that's what they call them.
And so, yeah, the realization that this is a separate species with distinct morphology and very, very distinct behavior is it's a very recent one. And actually, in a lot of ways, I think, and this is sort of a superficial thing, but I honestly think of bonobos as being much more like humans than chimpanzees in a lot of ways. And I think it's a convergent thing. Like, I don't think that they're obviously not genetically or phylogenetically closer to humans, but like.
Oh, it's close though. It's so close. It's common chimps beat them out by 0.1%. It's 99.8 for common chimps and 98.7 for bonobos.
Right. And I would say that phylogenetically they're equally distant from us because the common ancestor between bonobos and chimpanzees is the same as the common ancestor. Sorry, the common ancestor between bonobos and humans is the same as the common ancestor between chimpanzees and humans. So phylogenetically, they're equally distant from humans, but just from a superficial kind of just their shape of their morphology and their behavior, they seem a bit more like humans than common chimpanzees do.
Yeah, they spend more time on 2 feet. They've got sparser hair. They have limb proportions that, however slight, are still more similar to us than common chimps are. I mean, they're more cooperative in a lot of ways.
At one point, I showed a friend of I was talking about bonobos, and I showed a friend of mine some pictures, and my friend objected to one of them on the grounds that it was indecent nudity on the part of a bonobo.
Was it the mother walking across the water, where she's waist deep and she's just got clearly pronounced breast? And
I think she was. I think it was a female bonobo, and I think she was stretching or something.
Oh yeah, with her foot out.
Yeah, I know. And my friend was like, "No, I'm not comfortable with that picture." I was like, "Why?" It's like that looks too much like a naked person. I was like, "Okay, let's different thing." So yeah, bonobos are so human looking that apparently some people are uncomfortable with the fact that they don't wear clothes.
Yeah, there's an amazing bonobo rescue project called Loyola La Bonobo. And I think it's in the DRC. But I follow them on Twitter, or not on Twitter, on Instagram, and they do this really cool thing where they rescue orphaned bonobos from poaching and things like that. And because bonobos are so personable, they have to pair them with one human that acts as their surrogate mother and just takes them everywhere, carries them on their back, cradles them, whatever, and they basically surrogate them until a certain age. And the way that they knew to do this is that when they paired them with the surrogate mother, they just did way better, because very much like human children, they require that formative period to have someone. It's literally monkey see, monkey do. Like, they need someone to see and copy so that they know how to survive. It's really cute. I recommend, even if you're not into primates, like, it's a very heartwarming organization to follow. They're the only bonobo rescue in the entire world. It's really cool.
That is pretty cool.
Anyway, we're so off topic, Kane. I'm really sorry.
Well,
Again,
we're near the topic. So yeah, Kane, so in your data set, which by the way, do you have your raw data set as something that we could look at?
I'm sorry, what?
Do you have the raw data that you generated? Like, is that something that you have in a table or anything?
No, that's just what I gave you. Okay,
so what you gave me looks like the files that were essentially the experiment that you conducted, right?
Right. I haven't done much more than that.
Okay. Well, what I would recommend. I mean, yeah, it's great that look. In no way am I saying that you what are you doing playing around with Photoshop? No, this is a good idea. But what I would say is you should try to generate actual objective numbers, like pixel counts or something, right? Because I mean, is it as good as actually getting the a ruler up to the fossil? No, but then again, I mean, we don't have that option realistically. So
I would even say if this is something that you're super interested in, I'll just send you, like, after this call or later this evening, I'll just send you my research document that has like a bunch of papers, and a lot of them are like initial discovery included hypodymes, included measurements in the supplementary data. And if you really felt like it, you could go into Excel and just pull those numbers, and you could generate a pretty cool graph doing that. I actually don't know that. I don't know that I've ever seen one of those for each of the big traits. It would be really cool to see if you felt so inclined. If not, I mean, God, that's a lot of work.
What I'm saying, what I would find interesting, essentially, is take the things that you think are the most significant, right? Like you've called out, I think brain case size and maybe like foramen magnum angle, right? And actually get numbers that you can compare, like, you know, apples to apples, like this many cc's or this many, or, you know, this many degrees off of horizontal or whatever, and plug those into something like Excel, right? And then generate a graph where you can plot these points and either color code them or label them, and see if in fact the graph does have very distinct clustering, and if there are any of the individuals that you've plotted the graph for who are in the middle. Is there a little trail connecting the clusters? Because, you know, I would predict, one, there would be some clustering, but also I would predict that you're going to get, if you have a wide enough data field, you're going to get those individuals who are clustering towards the middle.
I would even, if you wanted to do this in like a relatively easy but like more broad way, I guess, a more encompassing way, I'd maybe pick 3 cranial traits and 3 postcranial traits from species that you know you can get 6 full traits from, and plot those, because that way it'd be really cool, I think, completely barring the discussion. It'd just be really neat to see. Kane, do you have anything else you want to talk about? I'm good. I'm still good on time. So whatever you'd like to discuss, by all means. I think that awesome. I mean, I genuinely think that it's awesome that you're like asking these questions and doing these experiments on your own. I think that that's really cool. And I had never thought to plug it all into Photoshop. I imagine that you got some really interesting comparisons doing that.
Yeah, which is, I would encourage you to get numbers off of the experiment and plug them into some program that can do some statistical analysis on it. You can get statistical analysis programs like for free.
I would recommend R, but I wouldn't actually recommend R because I hate it. I hate R. I hate statistics in general. I hate it. Gross. Miss me with that.
What's your R-squared valued on the data set there, Erica?
I don't have an R-squared value on my data set yet. I'm still collecting my literature.
Fair enough.
My stupid freaking thesis. I love my thesis. I'm just frustrated with it right now. I can't seem to find a consistent way to measure certain things because everyone wants to reinvent the wheel and do it their own way. And they're doing it in ways where it's impossible to be like, okay, study A measures X like this and study B measures X like this. How do I like standardize that method when like the people wrote these papers 5-10 years ago?
Are you
Very
saying
annoying.
that primatology has a problem with standard methodologies and that they seem to lack one?
Primatology probably has one of the biggest problems with lack of standardized methodology because there's so much behavior and no one wants to standardize behavior. One textbook tried to do that, Primates in Perspective, which I have behind me here. And when they did, everyone got really mad and was like, we're not doing that. Whatever. I'm honestly, and I asked my supervisor and he was like, yeah, that's a pretty big problem with primatology. And then I asked my data set guy and he was like, yeah, that's a pretty big problem. And I was like, okay, well, okay.
And then you just stumbled right into it head first.
Well, and the stupid thing is, inadvertently, I have no choice but to also create my own method because I don't have an option. There's no standard to do it, and in order to get everything to fit, I've got to like make my own way. It's horrible. I hate it. Get into primatology if you want to be frustrated all the time. That's
good advice. So there you go, everybody. If you hate yourself, be a primatologist.
Oh yeah, if you hate yourself but love primates, i.e., also yourself, then get into primatology.
All right, so I think my last big thing that I want to say in terms of the discussion we've been having is I understand that what you're seeing, Kane, although you haven't quite gotten to the point of having a quantifiable way to describe this. But you're seeing a gap between Australopithecines and genus Homo. And that's fair. But do you see why the consensus in primatology and paleoanthropology and evolutionary biology and all that is that while there may be some clustering, there is not a gap, because we have specimens that bridge the gap quite neatly, and that essentially everything that we're seeing in the fossil record for hominins, including, genus Homo and Homo sapiens and whatnot, is either matching a prediction or is retrodicted by the hypothesis that humans share common ancestry with, say, genus Pan. Because it doesn't matter if past that. Once we get to that point, we're at common ancestry with decidedly non-human animals. So, do you understand why the consensus says what it says?
Yes, I do.
Okay, that's good. Because
it's a different perspective, I think.
It is. It is a different perspective, and I get where you're coming from. Because I was coming from a similar position at some point. So it seems like you're the kind of guy who really wants to do the research himself. You want to look at the fossils. You want to look at the measurements. You want to do all that. And so my biggest advice that I can give you is, unfortunately, you're doing some science, and that means you're going to have to do some boring plugging numbers into programs and seeing what comes out. So what I would...
And describing methodology.
Right. So what I would say is, actually, it doesn't have to be super formal or anything, but like read a couple, like, paleoanthropology papers, right? And then just for yourself at least, write up a little paper. Say, okay, here's my method. Start, give your methods, give your figures, put your figures in, label them, plug all your data into a data set, into a, like a statistics program, generate the graphs, have the actual raw data listed, and then reach your conclusion, write that up, summarize it in an abstract. And like I said, this doesn't have to be like a 20-page formal paper with all the proper formatting and citations or whatnot. But just do all of that, and then ask some people whose opinion you think carries weight on both sides of this question. Well, I mean, that we would certainly be optional.
I'm flattered. I'm very flattered.
I would also say, send it to some other old Earth creationists that you know, and say, okay, this is my data, my conclusion, my methods. What do you think? Do you think that the data warrants my conclusion? What should I have added to the data, and things like that? And you can even then, if say Erica or I or anyone else is like, maybe you should include this specimen, you can add it to your data set, regenerate the graph and all that, and you can have sort of a running experiment that you're keeping track of, because that way you won't just have to take anyone's word for it. You'll know. You'll have the numbers.
I think that's superb advice. If you really want to do it, it can absolutely be done. And please, by all means, let me know.
Yeah.
If you want me to send you any papers. If this is something you want to undertake, I'm happy to help out in any way.
Yeah, and like we said before, this is not something that you need to feel like is going to be a big challenge to your faith, right? Most Christians, I can't say I know for a fact what the opinion is of most Christians, but I can say this. Most Christians, by far the vast majority, belong to churches or other ecclesial bodies that have either openly accepted evolution, including the at least physical common ancestry of humans to other apes, or belong to denominations or churches or other ecclesial bodies that have left it open to the members to decide, which means that they do not think it's in conflict, but you don't have to accept it. It's not their official position, but they see no problem as an official body. So basically, if you're a Christian, you can totally accept evolution.
Yeah, John Walton has some really cool books on that very subject. And there are some other really good ones out there by like Francis Collins, right, Dapper? The Language of God. Yeah, there's a lot of good stuff out there that exists for the express purpose of being like, okay, so when we look at it from a perspective of the natural world, does that impact, should that impact how we interpret scripture? And what about scripture as an isolate? Like if we exclude all the natural history and we use like an exegesis and say, okay, well, using scripture, what does it look like scripture says?
Yeah.
And there have been some really, really high level to me. I guess I can't say if they're controversial in their field because I don't know the field well enough, but there have been a lot of kind of hermeneutics guys who have looked at Genesis and been like, okay, it doesn't look like we've really got a huge problem here.
In fact, I would say that having read a fair bit of various kinds of theology, including Christians, that the theology that comes out of we need to take at least some aspects of Genesis quite literally ends up becoming somewhat simplistic and sort of like childishly comical. Like what you get to definitions of sin, like, oh, sin is, we broke one of these sets of rules that God had, and then you ask questions like, okay, well then how was it sin if you didn't know it was bad to break a rule because you didn't have the knowledge of good and evil? And you get to other definitions of sin where things are like sin is something that hinders our ability to basically commune with God, right? So these are things that take us and make us people who are less like God. So you get into this sort of like a virtue ethics sort of view about things like sin and righteousness and things like this. And it's easier to get there if you're going to not feel like you have to take the most simplistic, literal interpretation of, say, the Garden of Eden. And so I would say you can get into some really interesting theology stuff if you go that route.
I appreciate so much, though, Kane, that you reached out in the first place. I really do.
Oh, absolutely. Yeah, Kane, Erica and I have very mixed dealings with various creationists, and you are on the we like side of that bunch.
Oh my God, yes. I mean, it's it's all genuine, and like, you're gonna come to the conclusions that you come to the conclusions of, but at least they're yours.
Yeah.
I mean,
all right, so
I appreciate that more than you know. Yes, please. Let's just let Kane muse for a bit. I'm interested.
Absolutely, I want to hear this.
So, one of the problems with visually right here is that the Littlefoot specimen has a sagittal crest, so it kind of makes it look like its brain case is higher than it actually is.
I'm actually going to slightly turn down the opacity on the on these, just so I can get a better view of the. Yeah, there we go. So that way they're still there, but I can see, like, yes, I see the sagittal crest right here. Have you?
Well, it's just the point that the brain is actually not in that area. I'm not sure if Mrs. Plez is next in line on the layers.
So let's see. This is what I have next.
That's chimpanzee.
Okay. Then I have this.
Yes, that's Mrs. Plez.
Okay.
So you can see the difference between the more robust Littlefoot specimen and is it gracile?
Yes, gracile.
Gracile. Okay. That Miss Plez. So there you can kind of still see where the brain would be at on both.
So sagittal crests are typically a male trait. In many primates, for instance, gorillas, females lack a prominent sagittal crest.
Right.
So it could be as well that what we're looking at here is a degree of sexual dimorphism.
Well, Littlefoot, I'm pretty sure, is actually a female.
Is Littlefoot a female?
Pretty sure.
That I do not know. I guess we could try to look. It's also possible that we don't have a sex determination because it's not always easy with just a skull to make a sex determination.
Yes, keep going. I've just got this pulled up in the background.
So, basically, the idea is that these two Australopithecus specimens fall into the same. Compared to each other, they fit in the same area, right?
Yes.
Okay. So when you compare, if you take Littlefoot off the board.
Oh, yeah.
Sorry, Dapper.
No, that's fine. Do you want to put on someone else, or what are we up to?
If you take Littlefoot off the board.
Oh yeah, Littlefoot. Sorry. I'll
First skull.
put this back. Or what do you want on?
Just the Mrs. Plez.
Okay. Yeah, we're
Actually,
good there.
it might be Miss Plez. Can't remember. It's been hypothesized that it's also possibly a Mr. Plez.
So what is it we should be looking at right now?
The next slide up.
This one?
Yeah.
Okay.
If you can take the chimpanzee off of there.
Oh, did I have the chimpanzee? Oh, sorry, yeah.
So we could tell that Littlefoot and Miss Plez share the same area, right?
Yes, with you on that.
And they're quite different from this other Homo erectus, right?
Yes.
And that's the
Very
back.
much.
Is that the background? Yeah, that's the background skull.
Yeah. So what is the next step?
If I go up, I get this
Yeah.
skull.
Does it fall into the same range as Mrs. Plez?
Sorry, hold on. Continue.
I think that was a question for you, Erica.
Oh, flip us back one more.
Okay. So
Yes.
I'm good here.
So they're in the same range, pretty much, right?
I would say the only issue that I would have with that, I would say craniofacially, we see a more the prognathism is the same, but the nasal sinus is more projected forward, potentially indicating that we've got the emergence of a more protuberating nose. Protuberating? Is that a word, Dapper?
It's a word. I don't know if it's the
If it's
technical
accurate.
word. Yeah.
Also,
it makes sense to me.
Also note with this second one here, what you see is a more globular occipital area. So this human skull here, typically when we see
Oh, sorry, I can't see you.
That's okay. Typically when we see hominins, we see the growth of the brain occupies this kind of lower occipital area rather than like a more highly vaulted forehead or anything like that. So if you go back, Dapper, to the hominins very briefly, notice that when you switch between the two, you see something more you see a more exaggerated kind of underneath globular area. You see what I mean? It kind of hooks downward a little bit.
So we're saying that this one is a bit more derived than this one.
Yes, and I would say that that one, yes, is more derived mainly because it looks like I bet you're going to have a higher cranial. Damn it! I did it again. A higher brain case than you would in the former. I'm sorry. Continue. So that's what I would have to say. I would say that with regard to where it clusters, I would say that this one definitely looks more basal than our background Homo erectus. I would wager that what we're looking at here is maybe Homo georgicus, which was formerly the Demosini. I'm doing it again, aren't I?
Demonisi?
Demonici, yes.
Yay!
Demonici.
The dinosaur guy got the paleoanthropology thing right. Hooray!
Would I be correct in that, Kane?
I'm not exactly sure which specimen this is.
This is classified Homo erectus, yes?
Pretty sure it's still on the Australopithecus side.
I do want to point out that the fact that we're not confident is probably in and of itself an argument about the fact that these skulls are hard to put into bins that you can easily just label them.
I would say, yes, I would say for certain this one we're looking at rather than the former is more derived, in my opinion. Just looking at them. I've said before in past videos, and I will say it again, I am not a paleoanthropologist, and while I can identify some skulls, I definitely can't tell the difference between all of them.
Do we want to flip to the next one?
Yes, if it's okay with Kane.
Oh, well.
Absolutely.
All right. So
this one, if you notice, the backside of its head is kind of shrunk in comparison to the previous one.
Mm-hmm.
And the forehead is somewhat out of position too, in comparison.
So
my question would be more in line with accounting for potential for sexual dimorphism and accounting for life history. So, for instance, comparing Littlefoot to Mrs. Please, to my knowledge, they are classified as young adult versus later adult, which there isn't nearly as much changeover going on there when you're comparing that to, say, like juvenile versus subadult or versus young adult. But it would be something that when we're considering a transition, you would probably want to just keep in the back of your mind.
Right.
For instance, because when I'm looking at this pink skull at the foreground versus our classic Homo erectus on the background, what I'm seeing with this, my first instinct would be that if this foreground pink skull is in fact Homo erectus, which I don't know if it is or not, my instinct is that this looks more like Homo habilis to me, but that's just my thought. But this would be potentially within the range, assuming they're relatively the same size, and we could get a a cranial facial view from the front as well. But sexual dimorphism is a powerful thing. If you look at the difference between an adult male baboon or any member of genus Papio or Macaca and compare that to the females, it's not just the size of the canines and the overall size that's different. I mean, males have these enormous protruding brow ridges. They've got these weird nasal structures on the top. They're highly prognathic. So now hominins aren't nearly as sexually dimorphic as genus Papio, like not even close. But that being said, sexual dimorphism is something that is at play in the Australopithecines, not the Ardipithecines, but the Australopithecines. So it's something that you have to take into account as a possibility.
I mean, it's even in genus Homo.
Conceivably in genus Homo, I tend to lean towards, I don't think that we're seeing heavy sexual dimorphism for instance, humans are anywhere from 7 to 11% sexually dimorphic, in our overall stature, and that tends to hold pretty true for most members of genus Homo. Maybe a little bit more in Homo habilis, but that's up for debate from what I've seen. In fact, interestingly enough, even the Australopithecines now, who were previously considered to be potentially as stature dimorphic as like gorillas, they're thinking now that it's possible that that's overestimated based off of molar size that we're looking at, and that we might be because with primatology, it's always a question of two sexes or two species, because primates are weird with sexual dimorphism. But that's all. I'm not trying to say that making any claims about the pictures just yet. I'm just offering that up as something to keep in mind.
Okay.
Well, I'm pretty sure that I countered the sexual dimorphism problem by
Used all
using relative terms
right
instead of exact measurements. It's more of a relative, like if you compare it where the foramen magnum is here and the bottom of the axillary is here, and based off that, instead of like a direct comparison, because there is so much variety in absolute terms.
Yeah, no, I'm with you, and you're right. The foramen magnum should stay relatively consistent across the sexes.
Yeah, because as far as I know, there's no big stature dimorphism in any primate, is there? Or not stature, but like stance. Like we don't have
not locomotion.
Yeah,
for sure.
That would be a very strange form of sexual dimorphism. Do we want to go up to the next one?
If you could keep is it please or ples?
It doesn't matter. I've heard it both ways.
That's this one, right?
The one right before it, I believe.
Okay. So
you could keep that one up, and then we can go through the rest.
Okay.
Mm-hmm.
So that one, does it fall into the same as Australopithecus? You can tell.
Bleep it out for a sec, Dapper. Yes, I would say so. I'm comfortable saying, although the brain case is still growing larger, if I had that in a vacuum, I would be like, looking at the crania alone, it looks like an Australopithecine.
Okay. Can you
next one?
Change the opacity?
Oh, yeah. Give me a second. Oh, I'm on the wrong layer. Give me a second. Here we go. I know how to use a computer.
Okay, so how would you say that the brain case is getting larger?
I would say that in this case, what we're seeing is an extension of the back of the brain case. You see what I mean? Like in this direction, skull. In this direction, back here.
Oh,
This area, occipitally, I would suppose you would say.
Could you hold it up again for the folks at home?
Sorry, this area right here.
Okay.
Now, one thing I do want to point out as well is that the brain, even though it seems like it's not growing that much between the past two hominins that we're looking at in this direction, it's very minuscule. What you also have to consider is the breadth. So how wide or how much wider are we getting? Because for every extension in this direction, you are also, by definition, going to be getting an extension in this direction in overall volume. So I would say it doesn't seem like very much, but it is indeed still a growth.
Okay.
Okay, continue.
You want to go to the next one?
Sure.
Okay.
So this one I know is definitely off kilter.
Yeah, that looks like we're looking down from the left side.
Mm-hmm.
So,
But generally, would it still be in the Australopithecus range, would you say?
If this is within, if the grid lines are indeed like you're accounting for overall size and like the angle, whatever Dapper was saying earlier, and as well as sex, I would say so, yes.
Okay. Next slide, please. So this one. This is the one I had so much trouble the other night with. The transitional form. If you compare that to Mrs. Plez, what is the major differences?
and I'll drop the opacity down a bit so we can kind of get both of them at the same time.
Yeah, show me again, Dapper.
So we got Mrs. Plez. We got
Absolutely a much flatter face. This individual is much more orthognathic than Mrs. Plez is, and we see, go back to Plez again. And back once more. It looks like we're seeing almost a vaulting, the beginning of the vaulting of the forehead, however slight that may be. Basically, we're seeing an extension forward of the muzzle, and this part of the skull here is going downward, and the face is flattening. So I would argue that the main difference between the two actually has very little to do with the cranial capacity and very much to do with the differences in the face shape, which doesn't seem to be very people don't tend to think of that when they're thinking of the significant differences between a human and a chimpanzee, but actually is very much at play how prognathic the muzzle is and the face in general, because obviously there's orthognathism and prognathism with the face from the rest of the crania, and then there's also orthognathism and prognathism with the muzzle itself, which is the actual jaws.
now. Maybe I'm way off here, but it seems like right now in this skull we're starting to get into that area where the crossover between, say, Australopithecus and Homo erectus Homo is starting to get a little bit blurry. Am I wrong there?
I would say knowing the cranial capacity volume would be key here, because generally speaking, the transitionals, quote unquote, are going to occupy that 600 to 900 range.
Right.
Now,
but let's say all we have is these pictures in isolation. Are we?
I would say, yes, only because when we consider our hominins all lined up with one another, the brain case size is one of the last things to change, quote unquote. Like what we tend to see is the retained neoteny in the face before it is possible for the brain case to grow, at least to the extent that we see in late genus Homo. So I would say, like, if you showed this to me and you were like, who is this? I would say it's possible that we're looking at a basal member of Homo erectus, but I would also say it could be as early as Australopithecus sediba. If I was a betting woman, I would say maybe Homo rudolfensis.
Okay.
Okay.
So Kane, the reason I asked that is because you said you had problems with this skull, and to me it looks like it's right in the gap that not necessarily right in the gap, but it's bridging that gap that you have seen in your data. It looks like this is the skull that is sort of breaking that mold, where you're seeing distinct clusterings. And to me, this looks like the kind of thing that I would expect to see crossing over from one set of those clusters to the other. But, I mean, I could also be wrong because I don't have the measurements on this particular specimen. Although, handily, you can probably find them if you get access to the paper that that does that. And I'm not saying that you should pirate papers on Sci-Hub or anything. You should definitely not do that, obviously, because it would certainly be a tragedy to the world if high-priced scientific journals had to stop charging like $45 an issue because it was too easy for people to get free copies of their papers on a website that some Russian person made. Thanks for watching, but before you go, I'd like to take a minute to say thank you to my patrons and channel members on YouTube. They help me make this channel possible, and without them, I couldn't keep going. Specifically, I want to thank my $20 and above patrons, Bent Hovind, Ian Chen, Sphincter of Doom, Chris Love, Henry Hutanen, and Bob Knob. If you'd like to join the channel or become a patron, links are in the description, and if that's not right for you, but you want some other way to help out, there's also an Amazon wishlist, as well as a Teespring store where you can get Dapper Dino merchandise. If none of that works for you, just liking and sharing this video really helps out. I'm the Dapper Dinosaur.
So you found the skeleton. How would you tell it's a dinosaur? You personally, how would you decide?
Well, interesting question. I don't know. I'd have to do some research on this.